Hello there. In this video we're going to talk about how to locate the vertical and horizontal intercepts of a relationship or function, and sometimes these are referred to as the Y and X intercepts respectively. So let us consider the graph of a particular relation. Suppose that the relation that we are interested in is going to be this circle, and one can verify that a possible graph of this type of relation is given by x squared plus y squared is equal to 9. So how can we locate, or what even are the intercepts of a function? So this point here and this point here, if we assume that this is the x-axis, are referred to as the x intercepts, or the vertical intercepts if it corresponds to another axis. And this point here and this point here are referred to as the y-intercepts. And that is assuming that this vertical axis is the y-axis. So if it's the t-axis, then those are the t-intercepts. So how can we locate these points? Well, if we want to locate the x-intercepts, notice that they do not have any height above or below the x-axis, which means they have no y value. So one property of the x-intercepts is that the y value is equal to 0. Similarly, one can find out that the y-intercepts have a property as well, because their x value is going to be equal to 0 because they're not to the left or the right of the y-axis. So we're going to use these two properties to locate the x and y intercepts of, let's use this as our example. So example 1, suppose we have the relation x squared plus y squared is equal to 9, and we want to find the x-intercepts. So let's find the x-intercepts. So if we want to find the x-intercepts, that implies that y must be equal to 0. So if y is equal to 0, then this relation turns into x squared plus 0 squared is equal to 9, which is the same as the equation x squared is equal to 9. So of course we know that if we take the square root of both of these sides, that we get the absolute value of x is equal to 3, which means that x is going to be equal to plus or minus 3. So from here, what do we have? So we have that y is equal to 0 and x is equal to plus or minus 3, which is two numbers. So that means the x-intercepts are 3, 0, and minus 3, 0. Similarly, we can find the y-intercepts. So the y-intercepts. So for the y-intercepts, we know that their x value is equal to 0. So if that is the case, we can look at our relation and see that that should be 0 squared plus y squared is equal to 9, which is the same thing as y squared is equal to 9. Similarly, we can take the square root of both sides of this relation, and we'll get the absolute value of y is equal to 3, which implies y must be equal to plus or minus 3. So we have y is equal to plus or minus 3 and x is equal to 0. So that means the y-intercepts are, so the x value is 0, positive 3, and 0, negative 3. Let us look at another example to sort of illustrate how to find the intercepts. So example 2, suppose we have the function f of x is equal to negative 3 times x minus 2, the quantity squared, plus 7. We should be able to graph this relation, or this function, at this stage, because notice that we have our function. So what do we have? So we have this function, so we have this x-axis, this y-axis. This is a parabola shifted to the right 2 units and up 7 units. 1, 2, 3, 4, 5, 6, 7. So that's where the vertex of this parabola is going to be located. It's upside down because of this negative 3, and it's going to be compressed towards the y-axis, or towards the axis of symmetry. So it should look something like this. So based on this graph, what do we see? Well, we see that there should be two x-intercepts and there should be one y-intercept somewhere down there. So let's see if we can find this. So since this is a function of x, that means this expression is equivalent to the relation y is equal to that expression. So we're going to begin by finding the y-intercept, which means that x must be equal to 0. So if x must be equal to 0, then our relation becomes negative 3 times 0 minus 2, the quantity squared, plus 7 must be equal to y. So y must be equal to, say, let's see, negative 3 times negative 2 squared plus 7. Negative 2 squared is equal to 4, so we have y is equal to negative 3 times 4 plus 7. Negative 3 times 4 is going to be minus 12 plus 7, and negative 12 plus 7 is going to be negative 5. So that means the y-intercept is the point, so x is equal to 0, and the y value is going to be equal to negative 5. So similarly, we can find the x-intercepts by setting the y value equal to 0. So if that is the case, then we're going to have the relation negative 3 times x minus 2, the quantity squared, plus 7 is equal to 0. And now we need to solve this equation for x. I'm going to begin by isolating everything that does not have x in it. So I'm going to begin by subtracting 7 from both sides. So that's going to give me negative 3 times x minus 2, the quantity squared, is going to be equal to negative 7. I'm then going to move this negative 3 coefficient to the right-hand side. So that's going to be x minus 2 squared is going to be equal to a positive 7/3. And then I'm going to take the square root of both sides. And that is going to give me the absolute value of x minus 2 is equal to the square root of 7/3. And then I'm going to split up into its two components. So either x minus 2 is equal to the square root of 7/3, or x minus 2 is going to be equal to negative square root of 7/3. Then I'm going to add 2 to both sides of these equations. And then I have my two values. X is equal to 2 plus the square root of 7/3, or x is equal to 2 minus the square root of 7/3. So therefore, my x-intercepts are 2 plus the square root of 7/3, comma 0, and 2 minus the square root of 7/3, comma 0. The most complicated part about being able to solve for x or y-intercepts is being able to solve the equations that are resulting from setting x or y equal to 0. But if you're familiar with all the basic functions and all the equations that are associated to them, that usually is not too bad. But we'll discuss how to solve like quadratic equations, log functions, exponential equations, and so on later on down in this course. But for now, at least understand, you can find the y-intercepts by setting x equal to 0 and solving for y, and you can find the x-intercepts by setting y equal to 0 and solving for x.